Hello everyone, welcome to the TechnoGate here. So let's see some of the asymptotic properties here. So summation I equals to 1 to n I here. So what is this? 1 plus 2 plus 3 plus 4 plus 5 up to plus n. So what is this here? N plus 1. This is a summation of n natural numbers here. So here, what is the complexity here? Order of n square here. Okay, so we can write omega of n square and theta of n square also valid here. Theta of n square and omega of n square also valid here. Okay. Second one is like T of n is summation I1 to n I square. So what is this here? 1 square plus 2 square plus 3 square up to plus n square here. So what is this here? Is a summation of first n square number here. So what is n plus 1, 2n plus 1 by 6. So what is this here? Big O of n cube here. So here omega also allowed here and theta also allowed here. Okay. This one here. Next one is, third one is what? Summation I1 to n x raised to power I here. So what is this? Okay, what is the value of this one? Okay, let's see. So here x plus x square plus x cube plus x4 up to plus x raised to power n here. So what is the formula here? It is a geometric series here. So xn plus 1 upon x minus 1 here. So what is the upper bound here? Order of x raised to power exponential. Order of x raised to power n here. Okay, this one here. So this is the time complexity of these three series here. Now, is a very important topic is here. What P of n is n factorial. So how n factorial executed? n minus 1, n minus 2 up to 1. So n minus 1, n minus 2 up to 1 here. Okay. So what is the here? N into n here, big O of n raised to power n here. So T of n is n factorial is upper bound on n raised to power n. So this is upper bound. Okay, so this is upper bound. So this function growth rate is compared to this function. So n factorial is big O of n raised to power n here. So suppose that 5 factorial is what? Order of 5 raised to power 5. Yes. Means this one is upper bound on this one. Correct. Okay. But 5 factorial does not equals to 5 raised to power 5. Mathematically it is not allowed. Mathematically not allowed. But asymptotically it is allowed here. So 5 factorial is big O of 5 raised to power 5 here. Okay, this one here. Now, suppose that 5 factorial is omega of 5 raised to power 5. No, not possible, because this must be lower bound on this one. If we are using omega, means this must be lower bound. So not possible here, because this value is higher than this one. Not allowed here. And theta is also not allowed here. Theta means exact or not allowed here. So it is not allowed here. And it is not allowed here. This one is not allowed here. Okay. So this is allowed only. Only mathematically not allowed here. Asymptotically allowed. So in terms of algorithm, we can write this 5 factorial is upper bound of 5 raised to power 5 is allowed. Okay. So this one is the. Okay. So T of n equals to n factorial equals to big O of n raised to power n. So remember this one. So n factorial is upper bound on n raised to power n here. Clear? Okay. So these are the some of the series here. So we will take some of the problems, how to execute that problem here. So let's check one by one here. So let's check. This is a gate problem, gate 2002 problem here. So what is the problem here? Consider the following functions. Okay. So what is the function here? F of n is 3n root this one. 3 into n raised to power root n. Gn is what? Gn is 2 raised to power root n log n. And h of n is n factorial n. Okay. So which one is true? Which one is true here? So option A is what? H of n is bigger of fn. B is h of n is bigger of gn. C is what? G of n does not equals to bigger of fn. And D is what? F of n is equals to bigger of gn. Let's check it. Okay, how to execute this problem here. So first of all, take any counter example here. So here this is what? Here n raised to power n here. Okay, this is the n raised to power n here. So n factorial is upper bound on n raised to power n here. Okay, so now let's check this first one. H of n. So what is n raised to power n is bigger of fn is what? N root n. Constant never matter here because we balance the constant here. So here this is a n raised to power n here, but here root here. Suppose that we are taking like n is 4. Okay, n raised to 4 here. So 4 raised to power 4 equals to bigger of 4 raised to power square root of 4. So means what is bigger of 4 square here. 4 under root is 2 here. So tell me one thing here. 4 square is upper bound on 4 raised to power 4? No, because 4 square is what? 16 and 4 raised to power is 256. So 16 is upper bound on this one. No, not possible here. So A is false. Option A is false here. Okay. So take any counter example and solve this one. Okay. Next one is, so option A is false here. Now B, we will take B option. Option B is what here? H of n. H of n is what? N raised to power n is bigger of gn. Gn is what? So gn is 2 root n log n here. So what is this here? So here 2 raised to power log n raised to power root n. Again, this is a logarithmic property, this becomes once. And what is this? N root n. N raised to power root n. Again, same problem with this one. So it is again false. So B is again false. B is false here. Now C. C is what here? G of n does not equals to. G of n does not equals to bigger of fn here. Okay, so it is a false one. Gn and gn is also bigger of fn. Yes, because both are same here. This is a n raised to power root n here and this is n raised to power n root n here. So it is correct. So if here given like that, gn equals to bigger of fn, then it is correct. Then it is correct here. Then it is correct. But here not equals to, because gn and fn both are same. Fn equals to gn here. Both are same. Because it is again n raised to power root n and same here it is n raised to power n raised to power root n here. So it is a false one. Why? Because here given that gn does not equals to bigger of fn, but both are equal. Now D is what? Fn is bigger of gn. Yes. So if both the functions are same, then you can write fn is bigger of gn, okay, and gn is bigger of fn. Yes. So what is the answer? D. D for Delhi is correct answer. Okay, because fn and gn both are same here. So this is a very important problem, gate point of view. So take any counterexample and solve all the problems here one by one. Okay. So this is a very important approach here. How to approach that problem? Take an example, solve this. So try to minimize the functions. Okay. Try to minimize functions. Then take an counterexample and solve this. So this is a A, B, C, D is correct one. So maybe in GATE 2023 they may ask like which one is false. So A false, B false, C false. It's a multiple choice question. Here true, they may ask which one is false. Then A false, B false, and C false here. Okay. Now let's another one here. Next one is a GATE 2004 problem. What is the problem here? The time complexity of the following C function is where n greater than 0. What is this here? So int recursive int n, if n equals to 1 here, then simply return 1, else return recursive n minus 1 plus recursive n minus 1 here. Okay, this is the problem here. So these are the options are given here. What is the options here? Order of n, B, order of n log n, C, order of n square, and D, order of exponential. This one. Okay, so let's check one by one here. So what is the answer here? So in a recursive program here, so what is the time complexity here? So I already discussed that this problem here. So like here t of n is what? So suppose that recursive function is a t function here. So t of n minus 1 plus t of n minus 1 here, or we can add 2t n minus 1. Okay, and t of 1 is what here? 1. If n is 1, then return 1 here. So what is the time complexity here? Time complexity means is a approximated analysis. Time complexity means there is an approximated analysis here. So let's check here. Okay, let's check here. So this converted this in function. Now let's say, so there is no use of this. So after converting in this form, then there is no use of this one. So remove this one here. So now check what is the time complexity. So here t of 1 is 1 here. T of 2 is what? 2t, 2 minus 1 is 1 here. So 2 into 1 here is 2. T of 3 is what? 2t2. So 2 into what is t2 here? 2 here. It is 4. T4 is what? 2 into t3. So 2 into 4 is what? 8 here. So next one is what? T of n is what? 2t n minus 1. Okay. So here like how can I write like 1 2 raised to power 0 here? 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, and t of n is what? 2 raised to power n minus 1 here. Okay, this one, because 3 power 2, 4 power 3, and power n minus 1 here. So what is the time complexity? So we can write like t of n is what? Big of 2 raised to power n, approximation, 2 raised to power constant never matter here. So what is the higher order term here? 2 raised to power n here. So what is the time complexity of this one here? Order of exponential. Order of exponential. So D is the correct answer. So in this manner we can prove or we can derive directly. So what is the time complexity of this function is? This is a GATE 2004 problem here. Exponential. Order of exponential. Is clear? Now next one is So this is a very important problem. So take any counter example and solve that problem. Okay. Now the GATE 2007 problem here. So consider the following C code. What is the C code here? Int j comma n, j equals to 1 while j less than equals to n, j equals to j into 2, then the number of comparisons made in the execution of the loop for any n greater than 0 is. So first one is what? Log n plus 1, b is what? N, c is log n, and d is what? Log n plus 1. Okay, so how to approach this type of problem? Again, take an counter example. So through counter example you can solve any problem for any subject. Okay, so let's see this one. So here suppose n is 8, n is 8 here, suppose that. Okay, so if n is 8, then 1, j is 1 here, 1 less than 8, yes. So loop will execute it here and j becomes what? 2. 1 into 2. Okay, now 2 less than equals to 8, j is 4, 2 into 2, 4 here. Loop will execute it, j is 8, loop will be executed here. Okay, so here how many times the loop will be executed? 1, 2, 3, 4 times. For n value is 8 here. So 4 times means, okay, so here n is 8, so 8 times loop execute, no, is rejected. And here log 8 is what? 3 here. Okay, so but loop executed because j less than equals to n here. So there are 4 times here, not 3. So log 8 is exactly 3 again full. So b and c are false here. Now again this one, so log 8 plus 1, it gives 4 here, and log 8 plus 1 is a 4 here. So both options collide here. So take another example. Suppose that j is 7 here. Now j is 7. Loop will be executed, j is 2 here. Loop will be executed, j is 4 here. Okay, so j is 1 initially, sorry, j is 1 here, j is 1 here. So loop will be executed here. Now 4 into 2, 8. So here n is 7, here n is 8 here. So here how many times here? 1, 2, 3, because j is 8, so 8 greater than 7, no. So only 3 times it will execute. Only 3 times it will execute here. Okay, so now we have to check like a option A is log of 7 ceiling function plus 1 here. So log 7 is 2 point something, means 3 plus 1 is 4. It gives 4 because of ceiling function. So it is wrong because loop will executed only 3 times. 1, 2, 3 only. Now d is what? D is what? Log n, log 7 plus 1 here. So log 7 is what here? 2 point something, means 2 only because of floor function here. Plus 1 what? 3 here. So then what is the correct answer here? D. D for Delhi is the correct answer. Okay, so through any counter example we can solve any problem here. For any counter example we can solve any problem here. So what is the answer here? D for Delhi is the correct answer. Okay, so in this manner we can solve any problem. So there are very simplest problem in the GATE examination. So first of all your basic will be clear, your basic must be strong. Okay, so then everything will be easy for you. So next one is what? Again next problem, GATE 2008 is 7 IIT Kanpur problem. Let's check. Year 2008 problem here. So arrange the following functions in increasing order. Okay. So here A is what? Here A is n raised to power 1 by 3. B is what? E raised to power n. C is what? N raised to power 7 by 4. D is what? N raised to power n raised to n into log raised to power 9n. Okay. And E is what? Here 1.00000001. So your options are given like that. A, D, C, E, B. B is what? D, A, C, E, B. C is what? A, C, D, E, B. D is what? A, C, D, B, E. Now let's check one by one here. What is the option is correct here? Okay. So let's check here. So here I have how many exponential function here? This is B and this is the E here. So here B, what is the value of E? E base is 2.71. So definitely it will be larger than any other function. So here B, B, B and E. So it is wrong. So first of all try to eliminate the options. Here. Okay. So D is wrong because B having increasing function. B is the largest function here. Okay. Now next one is E because here some base is 1 point something is exponential function. Greater than 1, base is greater than 1, then definitely it is exponential function. So this is E. So here E, E and E here. Okay. Now next one is here C and D here. So C will compare and D will compare here. Okay. C and D will be compared here. So now let's check here. C is what? N raised to power 7 by 4 here. And here n raised to n log n. This one. We can write this one also. So here we can write like n and 1 by 3. So n into n raised to power 1 by 3 here. Or sorry. 3 by 4 sorry. 3 by 4 here. And here n log n raised to power 9 here. So here we can n and cancel out to try to convert in the functions form. So here n here log n. So this is a linear function growth rate is higher than this one. So it is smaller than this one. So after that B e raised to power n. Next one is 1.000001 n. So this is the E. Sorry, this is the B. This is the E. After that, here C and D here. So C is larger than D here. So here and raised to power 7 by 4 here. So it is the C here. So again option C is eliminated here. Because first of all larger function is B, then E, then C here. Again C in both in this. Okay. Now next one is what? So now A and D will be compared here. So A is here and D is here. Okay. Okay. So here let's check which one is larger than this one. So here n raised to power 1 by 3 here and here n log n raised to power 9 here. Okay. So here we can't write this form into separation. Okay, because it's a combination of n log n here and here. Okay. So something. Okay. So here power is 1 by 3 here, but power is a single. Okay, only 1 here. So whatever the value of n will be put here, definitely it's this becomes 1 by third part. 1 by third part cubic here, but here now there is no cube here. Okay. So what is the answer? So which one is larger than this one? D. This one. This one. Okay. So here is a n power is 1 by greater than 1 here, but here n power less than 1 here. So this is smaller. So A is a correct one. So function A is greater than. Sorry, A is smaller than D. So D is larger than E here. So here combination of this one. So what is the difference in this A and C? What is the difference here? Here n power more than 1 year, but here power of n is more less than 1 year. Okay, this is the main difference here. So what is the answer here? A is the correct answer. So there are many problems on the increasing order of numeration here. So there are already discussed some of the in previous part here. What is the increasing order of this following functions? So what is the order here? A is the order here. Okay. Now take next one here. So this is a GATE 2008 problem here. F of n is 2 raised to power n. G of n is n factorial. H of n is n raised to power log n. So which one is a true? Option A is Fn is big of Gn and G of n is big of Hn. What about B here? So B is what here? F1 is omega of Gn and G of n is what? Big of Hn. Now C is what here? G of n is big of Fn and H of n is big of Fn. Now D is what here? H of n is big of Fn and G of n is omega of Fn here. So now let's check one by one. Which option is correct here? Okay. Which one is correct or false here? So now let's check here. Fn is big of Gn here. So Gn is what here? Gn is n raised to power n. Okay. This is a very large function. Okay. So here Fn option A is what? Fn is what? 2 raised to power n is big of n raised to power n. Yes, it is correct. But second one is wrong. Why? Because Gn is n raised to power n is big of Hn is n raised to power log n. So if base is same, then power will be compared here. Power is n here, here log n here. So n and log n, which one is bigger? N. So it is A is a false. So A is a false here. Because of this one. Because of this one. It is correct. Fn is big of Gn. Because Gn is larger than Fn. Yes. Any polynomial function growth rate is any exponential function growth rate is any polynomial except this one. This is a very, very large function here. So A is false because of this one. This is correct one, but this is wrong. Now B is what? Fn, what Fn here? 2 raised to power n omega of G n raised to power n. So this must be a lower bound. This is a lower bound. It is saying this is a lower bound, but it is upper bound. Okay, false because of this. First part is on, so no need to check further here. So here say Gn is lower bound on Fn. No, not possible here. Now C is what? Gn is big of Fn. Again false here. Fn Gn is this one n raised to power n is big of 2 raised to power n. False one. Because this is a polynomial, this is exponential, but except this one, this all polynomial are smaller than exponential, but except this one. So C is again false. C is again false. Now Hn. Du is what? N raised to power log n is big of Fn. Fn is what here? 2 raised to power n. Yes, correct. It is a so and Gn is what? N raised to power n is omega of Fn is what? 2 raised to power n. Yes. This is a lower bound. This is a lower bound. Okay. On n raised to power n. Yes, you know. But D is the correct. D is the correct one. Okay. This is the correct one. Now, next one. So this type of problem we can solve in very easy manner here. Okay. So you know very well how to approach the problem. Okay. This one. So this is one of the GATE problem also. Now next one. is a gate 2017 IIT Roorkee here. So consider the following C function. So int fn, fun function here, int n, int I comma j for I equals to 1 here, I less than equals to n, I plus plus, for j equals to 1, j less than equals to n, j is less than only, not equals to n, j plus equals to I, and printf percentage d I comma j here. Okay, so what is the time complexity? Okay, in terms of theta notation, so is theta of n root n, b is what, theta of n square, c is what, theta of n log n, and d is what, theta of n square log n. Okay, let's check here. What is the answer here? So here, so take any counter example. So what is the meaning of this one? J equals to j plus I. J equals to j plus I here. So let's check here. So I is 1 here. Suppose that we are taking n equals to 1 here. N value is 1 here. Okay. So if the value of n is 1 here, so I is 1. 1 less than 1, yes, inside the loop here 1, then condition change, 1 less than 1, condition false. So for value of 1, for n value is 1, it will never execute. It will never execute here, okay, it will never execute here. So here means 0 time execution here. So here it gives the on 1 time, here it gives 1 time here, but here log 1 is 0, here log n is 0. So log n is 1, 0, 0 here. So A is eliminated here, B is eliminated here. A is eliminated here, B is eliminated here, okay. So for n value is 1 here, okay. So it will be executed, but this one inside a loop, inside j is 1, 1 less than 1, never executed, outside the loop. So for n value 1, it never executed here, okay. So now let's check here. So what is the first loop complexity here? N. It will execute n time here. It will execute n time here, okay. So in C is what? N into log n, okay, and D what? N square into log n here, okay. So first loop will, there are 2 for loop, means there are combination of the multiplication of 2 complexity here. So first loop will execute n time here, okay, not n square time here, and this is a j equals to j plus I. So every time j will be incremented by I here. So here executed on the log n time only. Here executed on the log n time here, okay. So whenever it increases by the sum of the variable, then complexity always in the logarithmic terms here. So here n square first loop complexity. So first loop is n time only, this one. So log n. So what is the answer here? So D is false here. C is the correct answer. C is the correct answer here. Okay. C is the correct answer. Okay. So in this manner we can execute one. Take the counter example and solve any problem. Okay. Solve any problem here. So this is a very simple exam here. So there are so many types of problem. This type of problem here. So we will discuss about one by one. So next very important problem is so this is the GATE 2022 problem. So it's a very important part. GATE 2022. Which one of the following statement is true for all positive functions fn. Option A is fn square equals to theta of fn raised to power whole square when fn is a polynomial. B is what? F of n square is small o. This is a small o here. F of n whole square, this one. C is what? F of n square is big O of f n whole square. When fn is a exponential function. Okay, and D is what here? F of n square is omega of this one. Okay, so let's check one by one here. Okay, so here which one is true here? Okay, so suppose that like a f of n is like taking n cube here. F of n is n cube here. Okay, so check option A here. So A is what here? F of n. So here n is what? N cube here. So n cube whole square is a theta of f of n. F of n is n cube whole square, this one. So here what? This one is f of n raised to power 6 is theta of n raised to power 6. Yes, it is correct. It is correct for every value. Fn is only polynomial function, so it is a valid for every polynomial. Like suppose that we are taking like that, fn is n square here. Fn is n square here. So what is fn here? So n square raised to power square is, okay, so this one fn here, so equals to theta of fn is what here? N square whole square. So here n raised to power 4 is a theta of n raised to power 4, exact bound here. Okay, exact bound. So A is a true. A is true here. Okay, now B, we have to check B here. So in B here is small o. So in small o it is not valid for the equal to part here, because here what is the condition here? Fn less than only C dot Gn here. So we never compare equal function here. But if we take fn is n cube here, then both gives it same value LHS and RHS. Okay, because it is showing the upper bound, those upper bound may be tightest or not tightest here. So here equal not allowed here. So if we take fn is n cube here, so here n raised to power 6 here is small o n raised to power 6. So not valid here, because what is the condition for small o? Fn less than C dot G. Equal to not allowed here. So it is false. So it is false one. Okay, so it is false one here. Okay, now check C option. So C is a very important. Fn is exponential. In a C already given that Fn is exponential. And A is given a polynomial. So it is valid for all polynomials. Now check it. C is, so here let's check. Fn is e raised to power n. Fn is e raised to power n here. So put C here. So Fn is e raised to power n whole square, and big of Fn was e raised to power n. Okay. So here en square and Fn is e raised to power n. So here Fn is what? N square. N is what? En whole square. Okay, and here e raised to power n 2 times here. Fn is 2 times here. E raised to power n, e raised to n. So what is the meaning of this one? Big of Fn into Fn 2 times here. So here e raised to power n square is big of e raised to power 2n. Okay. So whenever the power are same, sorry, base are same, when base are same, then power comes. So here power is n square, here power is 2n. So which one is greater than n square is greater than 2n? N square greater than 2n here. So this must be upper bound. This must be upper bound for this correctness. But here this is not upper bound here. This is lower bound. This one is upper bound. This is upper bound here. So C is false. C is the false one. Okay. C is the false one here. C is the false one here. And D is also false here. D is also false here. Okay. If bigger is false, then definitely D is also false here. This must be a lower bound on this one. So not possible here. So A is the correct one. So option A is a correct one. So if you take like a Fn is 2 raised to power n here, then definitely it gives a wrong answer. Okay. Option D. So if you take like Fn is 2 raised to power n here, okay, then here same 2 raised to power n square, okay, and omega of 2 raised to power n into 2 raised to power n here, okay. So 2 raised to power n square here, so this becomes 2 raised to power 2n, okay. So this is a false one here. Okay. This must be a upper bound, this must be a lower bound on this one. That is not possible here. Okay. Clear? So D is a false one. So only A is correct here. Only A is correct. Okay. So option A is correct here. So this type of problem asked many times in the GATE examination. So try more and more this type of problem. Okay. So we will discuss a more important problem in the upcoming lecture. Okay. Thank you everyone.